All right, the final shape we'll be doing for surface area is a pyramid. And a pyramid is just a shape with a rectangular base, and all these bases can lead up to a common point of a vertex. So, like before, the rectangular base has dimensions W and L for width and length, and this overall shape has a height of h. One thing to remember about pyramids is that if this is a perfectly right and even pyramid, which is almost always the case of the pyramids you'll be working with in grade 9 curriculum, then the h would fall to the exact center of this entire rectangular shape. That means that if you have a rectangular shape right here, the h will fall right here so that it separates the width into two sides, and that it separates the length into two sides that are perfectly equal. Keep this in mind for what we're going to be doing later on. All right, just like before, when analyzing for the surface area of this pyramid, we're going to be summing up or adding up the surface areas of the different faces of the shape. So let's start off with the obvious, the rectangle on the bottom with dimensions W, L, and therefore an area of WL. Pretty simple. But now we have to analyze the 4 different triangles on the sides of this overall pyramid. You notice that when looking at these triangles, you have the bottom base, but you don't have a corresponding height of just the triangle itself to determine the area. And to do this, we'll once again turn to the Pythagorean theorem and right triangles to find the side that we need but we don't know for now. If we look at this triangle right here and draw out the height it's supposed to have, let's just say that it has a height of h1 maybe, all right. Then you'll find out that if you connect this point right here to this center point where the overall height of this pyramid, you'll find out that this, once again, is a right angle triangle of 90 degrees. And so therefore, if we could draw this shape right here out, you'll find out that h1, h, and this length right here, as I said before, since this is a perfectly right pyramid, this point would be the center of the center of the rectangle, and therefore it should cut every single side perfectly in half, and therefore right here would be 1/2 of L. You can kind of see that, right? This would be 1/2 L, since right here would also be 1/2 of L. Pretty simple. And with this and the Pythagorean theorem, we can relate it as h1 is equal to square root of L squared over 4, so 1/2 L squared, plus h squared. You could do the same with all the different sides of this rectangle, and you'll notice that right here, this side, so the side that's kind of on the opposite side of the side that has hi, also has a height of hi, but the other two sides may have heights of h2 or another height. And it looks a little complicated, but once I draw it, it'll make more sense. So you have 2 triangles of bottom of W and a height of hi, and you have 2 triangles of bottom L and a height of h2. So to summarize it, the surface area of the pyramid would be equal to WL for the rectangular shape on the bottom, plus 2 times 1/2 of W times hi, standard formula for the surface area of a triangle, plus 2 times 1/2 of the L times h2. And we have a 2 since they're corresponding there are 2 triangles for each shape. If we summarize this even further, the 2 and 1/2 cancel out, equals WL plus WHI plus LH2. And to summarize this even further, since the HI and HL, and H2 can be, the HI and HL 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 can be, deduce even further, is equal to WL plus W times HI we said was L squared over 4 plus H2. And by the same logic as before, LH2 is equal to L square root of W squared over 4 plus H squared. And with that, we have the surface area of our pyramid.